All right, everyone, welcome back for the second review video to getting ready for our first quarterly. So in here, we're going to start off the same way we kind of started off in quarterly review 1. This time we're rewriting the following expression into standard form. Now remember, standard form means we want it from the highest to lowest exponent when we combine like terms. And we're going to also identify the leading coefficient, the degree, and the constant. So what I'm going to do first is just think about PEMDAS for a moment. So when I think about PEMDAS, we think about our parentheses, our exponents, multiplication and division come together, and adding and subtracting come together depending on what comes first, left to right. So if I look at my two parentheses sets, x minus 5, there's nothing I can combine inside there. Same with x minus 1. Those are not like terms. So then I go to the next spot, e for exponent. What you need to remember here is anytime that you have x minus 5 squared, that's the equivalent of having x minus 5 times x minus 5. You are squaring it. So something squared means it's anything times itself. So by having that, I'm going to end up double distributing, right? You might remember it as double bubble, but I'm going to have x squared, and then I'm going to distribute x times a negative 5 is a negative 5x. Negative 5 times x is also a negative 5x. And we're going to get negative 5 times negative 5 for a positive 25. Again, remember, when you're doing this multiplication, you cannot plug x into your calculator. Only x can be plugged in when you're using y equals feature. So you're just multiplying the numbers in front. So it's like multiplying a negative 5 times a 1 to get a negative 5, and then the x is attached. And if I want to, I can go ahead and combine here, because I do have like terms of those negative 5x's. So we get x squared minus 10x plus 25. It is important to remember that distributing means that there should be a term in between, because if we forget about that, then we tend to have a little bit of an issue at the end. Now, what I also want to remember is that I still have this 3 in front of that x minus 5 squared, as well as still having 4 times x minus 1 that we haven't tackled yet. But now that I've done my first part with the exponents, now I can go and do that multiplication. I have the numbers in front of parentheses, which leads to division. So 3 times x squared is going to be a 3x squared. 3 times a negative 10x is going to be a negative 30x. And 3 times 25 is going to be a positive 75. Same idea here. 4 times x is going to be a positive 4. And 4 times a negative 1 is going to be a negative 4. At this point, I'm ready to do my combining of like terms. So I have here, only thing with an x squared is that 3x squared. So that's going to stand alone here. And we're going to write that in front. Remember, in standard form, I'm trying to write the highest to lowest exponent. So I'm going to start with that squared, so that way it's already in front for me. Then I take the negative 30x. That's going to combine with the positive 4x here. So we're going to end up with negative 26x. You're doing negative 30 plus 4 in your calculator. Remember, you're excluding the excess from your calculation, because then we'll get something wonky. And then we have positive 75 minus 4 to get a positive 71. Now, we're not quite done with this question altogether yet, because we also wanted to identify the leading coefficient, the degree, and the constant. The leading coefficient is exactly what it sounds like. It's the lead. It's the number in front when you're already in standard form. I know I'm in standard form because I have the highest exponent first, and it goes down to x, and then there's no exponent, there's no x at the end. But my leading coefficient then is this number in front. That is going to be 3. The degree, that is your highest exponent. It's the greatest piece that goes in there. So our degree in this case is 2. And finally, the constant is exactly what it sounds like. The constant is just a number with no variable to manipulate it. So our constant is the 71. That's from our first unit, and that's just knowing those vocab terms. So just recap those vocab terms as we go through. Additionally, number 2 is also from Unit 1, and it's just about our properties. So we have John, who was given the equation 4 times 2a plus 3 equal to a negative 3 times a minus 1 plus 31 minus 11a. Some of the steps are shown for us already, and with that, we're going to kind of justify the reasonings why as we go through. Now, the first one's just the given. That's exactly what we pulled out from the equation of the problem when we were reading through 2. So what I want to do is figure out what's different. So when I look here and I examine, I notice that these parentheses are no longer there. And if I check out here, it seems like we've made that -3 go into both parts, like the 4 went into both parts. Remember, that's your distributive property. If your parentheses disappear and you've multiplied the outside number to both parts or all parts inside the parentheses, that's your distributive property. Now, I combine like terms in the next stage. So what they did here, if I'm looking at my combining like terms, I can see that -3a and -11a became -14a, just like I can see 3 plus 31 became 34. So that's what they did over here. But now I want to look what happens. So if I'm looking about what changed in here, I can see my 8a changed to a 22a. I still have the 12 and the 34 in the same spot. So the only thing missing is that 14. So that means I moved it so that a was on one side. So I added 14a to both sides so it would have canceled on the right. So whenever you add something to two sides of the equal sign, that's your additive property of equality. Now that's the formal name. If you did something about like the addition property or just said that you added 14a to both sides, I think they would still allow that. But the formal name is the additive property of equality. It's basically that I'm adding both things to each side of the equal sign so that I can have a on one side, so I'd be setting up to solve. And that would be it. As we get into the next one here, we're looking at which table represents a function. There's one key rule to functions, and it's that x cannot repeat. So anytime you're looking for x to not repeat, in here you have 4 tables. You're just looking at the x values. We don't care about the y at all. First one, no good. 2 and 4 repeat each time, right? Number 2, 0 and 0 are repeating, so that's no good either. But if I look at 3, 3, 5, 7, 9, no repeats, all good. In 4, we see the zeros repeat again, so that would not be good as all. But 3 has no repeating x values. That way it's a function. Now for 4, we want to write an equation of a line here. So I have 2 points that we know the line is going to pass through. So as I'm looking at that, I'm going to first realize my equation of the line that I like the most is y equals mx plus b. And there's going to be other ways we can do this as well, but we're going to come back to that in just a second. So the first thing I need to be able to do here is solve for m. And again, m is your slope formula. y2 minus y1 over x2 minus x1. I'm plugging these points into my calculator, but I want to make sure you can go ahead and label them if it's easier for you, x1 and y1, x2 and y2. It doesn't matter the order in which you do this, but you have to know that x and y always goes as a package deal in the parentheses. So I'm going to take 7 and I'm going to subtract a -5. And in that same way, since I started with 7, I'm going to start with -1 and I'm going to subtract a 2. And at this point, this can be plugged right into your calculator. You can do your alpha y equals and make the fraction and let it do the work, right? You have this fraction tool. You might as well let it do the work for you. You can do it by hand, but either way then I'd end up with a 12 divided by a -3. So my slope is a -4. So that's the first stage. We get our slope here. Now my second part of this is going to be finding what the y-intercept is, because I've just found m, I need b. You can use either point now, and we're going to plug into y equals mx plus b. So again, I've just found that 4 is m. I can use either one of these points. So I'm going to say I use the first one. Y would be -5 and x would be 2. Again, if you use -1,7, that's totally fine. Either way works. But I'm just going to solve here. -5 is equal to 4 times 2, which is 8, plus b. And then I want b by itself. So I subtract 8 from both sides. -13 is equal to b. If you're someone who used the -1,7, it would have worked the same way. You would have had 7 equals a -1 times 4 plus b. we would have a negative 4 plus b on the right side, and you would add 4 over, and then we would be good. Oops. Whoops, let me just realize something. As I was going through and I recapped that, I just realized one thing I want to switch, so bear with me. And this could happen to anyone, right? So let's make this quick correction. It's not a positive 4 that I have in there. It is a negative 4. Whoops, sorry about that. So I'm going to go real quick and fix exactly what I had. Negative 5 is actually equal to a negative 8 plus b, and the opposite of a negative 8 is going to be positive. So we're actually going to get a positive 3 in for b. So good thing I was walking through about how the negative 1, 7 works, because as I was checking that work, I noticed that that did not get us the same answer. So now I have b. Now I can write the equation of our line, and that is going to be y equals negative 4x plus 3. And this is just one way you could have wrote it. Now, most of us said in class that we like this y equals mx plus b method too. If you're someone here, there's also another way to write an equation of a line. It's called the point slope formula. Y minus y1 equal to m times x minus x1. And then it's a little bit less work if you memorize that formula, because if you have the slope that we got in the first part, that negative 4, you can just plug in either one of the points, and that's an acceptable answer as well. If you have questions on that, feel free to ask me in class, but that's just another method of how you could do this. Okay, for something like this, we could look at this graph, and it shows the distance in miles m hiked from a camp in h hours. Which hourly interval had the greatest rate of change? So we just got to think about what that even means in context. We're thinking about what we're trying to look for. And nicely enough, each of these increments are just 1 hour apart, right? It's 0 to 1, 1 to 2, 2 to 3, and 3 to 4. So we're trying to see the steepest slope. We want to see where it increases the most. So when I'm looking here and I look at that, let's think. We're going up 2 over 1, so my slope there is 2. In the next section from hour 1 to 2, I'm going up here. Now this is up 1.5 because it's going to 3, and then this is just 3.5, right? So we're counting, even though it's up 3 boxes and up 2, you can think of it as that, like each is a half here, because this is the same equal amount on the bottom, like each is a half down here. So if you think of up 3 over 2, we're getting 1.5. Same thing in the next one. We can think up 1 over 1. Oops, let me switch the color up just so. Since I already used the blue, it doesn't really matter, but if I'm looking at that, just so when you're looking back, up 1 over 1, my slope is 1. I can kind of see this each time, so it's up 1 over 2 here. And then I have a slope of 0 on this last part. So the greatest rate of change was our first one, up 2 over 1. So you can see that, and you can count the slope, because remember, the slope is the change in y over the change in x. You could calculate each point, but we could just look at the graph. We have it there to choose from. All right, so this is another one like we saw in the first quarterly review. It's telling me here to rewrite this, though. So I'm doing 2 and times everything that is c. So 2x minus 5, what's c in this case? And I'm going to do minus 3 times everything that is in for d, x squared plus 3x minus 2. Keeping in mind that this time it does say to rewrite it in standard form, where we didn't have to in the last one, but that's why I said we should practice that continuously through. So in here, I'm going to take 2 times 2x. 2 times 2 is 4, and the x stays. 2 times a negative 5 is going to be a negative 10. Negative 3 times x squared is just going to be negative 3x squared. Remember, there's like an imaginary 1 in front of x squared, so it's like having negative 3 times 1, and then we just keep that going. Negative 3 times positive 3 is a negative 9, and the x continues to follow. And negative 3 times negative 2 is going to be a positive 6. Now we've done all of our distributions. We've combined those here, or rather we're getting ready to combine like terms. Again, because of this standard form, I'm going to start with the highest exponent. Negative 3x squared is going to lead off here. Negative 3x squared comes first. It's the only thing with x squared, so we don't combine it with anything, and that would be our first component. Now, x's include 4x and negative 9x. So 4 minus 9 in our calculator is going to be a negative 5x. And negative 10 plus 6 is going to be, negative 10 being bigger is going to be at negative 4. So I wrote it in standard form, highest to lowest exponent. It goes down. My leading coefficient would be a negative 3. My degree would be a 2. And my constant would be a negative 4. We didn't have to write those things in. It didn't ask for it. But just to recap it along the way. Okay, next one. We're back to talk about functions here. We have Nora says that a graph is a function of a circle is a function because she can trace the whole graph without picking up her pencil. Mia states the circle graph is not a function because multiple values of x map to the same y value. Determine if either one is correct and justify completely. I'm going to suggest let's draw a set of axes, right? We know we have our x, we have our y, but I'm just going to draw a circle on here. It doesn't have to be perfect, rough shape here. Now, I did go around in one fluid motion without picking up my pencil, so Nora's correct with me picking it up, but remember, this does not pass the vertical line test. The vertical line test is when we draw in any vertical line to test if it hits our graph more than once. X cannot repeat, so in this vertical line, there's there's one x value for multiple y values, so this is not a function. So Nora, no good. It is not a function. But now that Mia says it's not a function because there's multiple x that map to the same y, that means x is repeating. So Mia is correct. We want to specify who's correct. And we justified by a picture, but I can even say the circle does not pass the vertical line test. Okay. We are ready to keep it on moving now. So we're back to graphs, right? We feel good. We already have it in y equals mx plus b mode for us, which means I know automatically that my y-intercept, my starting point, is at 7. Positive 7 along the y-axis is going to be from the origin up 7 units. And I know my slope is a negative 3 over 2. That means we're going down 3 and 2 to the right. So from this one point, I'm counting down 3, 2 to the right. I'm going to keep repeating that process along the way. You don't have to include all the dots that I did. If I want to go up 3 and 2 to the left, I can as well. You can include every point if you want to, but you don't have to. You can do like 5 solid points we talked about. But I am going to draw that line in here, and I can go ahead and label that y is equal to negative 3 over 2, x plus 7. So I knew it was a negative slope, so I should be looking at a graph that curves or goes down when you're looking left to right. It started as a positive y-intercept. And you could also go right into your graphing calculator feature of y equals and type that same thing in, right? You go to y equals, you look at your table, and you call back on that as well. Now, the second part can be answered in 2 ways. The first is by seeing where this point is on the graph. So if I look for the point 2, 4, I'm looking at this point right there. The point is on your graph. It is a solution to the equation. So I can say yes, 2, 4 lies on our graph. The other thing that you can do to answer this with full credit as well is remember what we did before. X and Y are a point. I can plug in 4 into y equals, I have negative 3 over 2 for the slope. X would be 2 plus 7. And I'm just going to type this right into my calculator. Negative 3 over 2, so negative alpha y equals, enter to get a fraction. 3 over 2 times 2. And we would get plus 7, and they equal 4. So if I plug it in, this is also a valid reason to why that this is a solution to my equation. I can also look at my table, right? If I have the graph already and I go to second graph on my graphing calculator, I could see that as well. So we know that it is a point on there, and we move forward. All right, I've got a similar question to one from before, which does not represent a function. Our big idea is that x can't repeat. So as I look to number 1, easy enough, no repeating x values in that table, so that one's out. As I look to the next one, I can draw any vertical line in there. It's only going to hit once, so this is in fact a function. My third one, you can go in to y equals and plug this in and just get a quick visual what this looks like. If you plug this into y equals, you'll see the graph, and you'll see that it's still going to only have 1x for every y. But if I kind of look at the more obvious one here, right here, 1 has the value x having 2 outputs, right? That's like having 1 goes to 4 and 1 goes to 5. X is repeating. X is also repeating at 2 and also repeating at 3. So I definitely see x repeating here, and I know choice 4. 3 is really thrown in there to kind of throw you off your game, but you could plug it into the calculator and get a picture of that. And I'll add a side video to show you how exactly I would do that, just to recap that as well. Now, for 10, a grocery store sells packages of beef. The function C of W represents the cost in dollars of the packaging, or the package of beef weighing W pounds. The most appropriate domain, now remember, domain and range go together. Domain is your x values, also known as your inputs, what you'd be plugging in, because we always plug into x, where range is your y values, also known as your outputs. It's what you get out of plugging x in. So if I'm thinking about the domain, the function C of W represents the cost. This is your output. So right here, the cost is the output. So it's in dollars, but it's relying on package of the beef weighing. So pounds of beef is your domain here. So now I have to think about it. Now there's ways around this here. Once I see that positive, that should kind of trigger me as a thought here, because automatically I'm going to cross off 1 and 2, because integers and rational numbers can be negative, and you're not going to be purchasing a negative amount of beef, right? You're not going to get paid because you didn't buy any beef. Like, that just doesn't even make sense. So let's make that a little bit easier for us, and we automatically cross off 1 and 2. Now, it's important that we remember our number types from our first unit. That's a big vocab unit we had. So integers are numbers that could be like -3, -2, -1, 0, 1, 2. But we know we only have positive, so we're talking like 1, 2, 3, 4, and that's fine. But rational could include decimals, like nice decimals, like maybe a quarter pound or half a pound, which is something we can realistically order beef in. So the best answer here is going to be for positive rational numbers. All right, last page, just a few questions left. 11 again is a question that's just asking me to identify the property. So as we identify our property, this is just from unit 1. So I'm going to look here to see what's happening different from Kate's equation. So we have p squared plus 5 equal to 8p minus 7. So as I look, I still have the p squared in both sides, so that didn't change. The 8p is still on the right, but 5 and -7 has now become a 12. So the number is completely gone from the right side of the equation. So the opposite of a negative would have been to add, which checks out, because 5 plus 7 would have been 12. You're adding to both sides. That's going to be your addition property of equality. Okay. I think we've got just 2 more. And these 2 are our most recent unit, our piecewise functions unit. So in this next one, the equation to determine weekly earnings of employee at the Hamburger Shack is given by W of X, where X is the number of hours worked. Determine the difference in the salary in dollars for an employee who works 52 hours versus one who works 38. So this is really a plug-in question, and we're just looking at to where we would be plugging in. So I'm going to start with this 52 hours. Now, 52 hours cannot go into this first one because 0 is less than or equal to 52 is less than or equal to 40? Well, that doesn't make sense at all, right? 52 is not in between 0 and 40, but 52 is in fact greater than 40. So when I go to plug in, I'm going to plug into the second equation. I'm going to plug into the 15x minus 40, and I'm going to plug in 52 minus 40 in here, plus 400. So I'm going to start with that part. So at this point, this is just a question for me to plug right into my calculator. So take a moment and plug that in for yourselves, and let's see if we get the same thing. As I'm plugging it in, I'm doing my 15, I'm doing parentheses, 52 minus 40, exactly what's in the right what we wrote down. That's the point of writing this all down nice and easy for us. So I'll just give it in a second here, but you should end up with 580. Okay, if you didn't get that, take a minute, retype that into the calculator and see if you can figure out where your mistake was. So pause the video if you need to. In the next part, 38 does fit in between 0 and 40, right? 0 is less than or equal to 38 and it's less than or equal to 40. So I'm plugging into the first equation. So that's just 10 times 38. So that's going to get us 380. You can plug that into the calculator as well. My last part here says that I want to find the difference. So remember, when we're talking about a difference, we're subtracting 580 minus 380. So we are talking about a $200 difference. Okay, that's how we go about that first part. The second part here, determine the number of hours an employee must work to earn 445. Well, I don't know which equation I'm plugging in because I don't know the hours. I don't know the x value here. So I'm going to try to plug it into the first one and see what happens. So we have 10x. And let's say that's equal to 445. So that's a nice easy cell for us. We divide by 10 on both sides. So x is going to equal 44.5. Now, I run into an issue because when I check, 0 is less than or equal to 44.5, less than or equal to 40. Well, that can't happen, right? 44.5 is not in between 0 and 40. So it was not the first equation we would need to use. So instead, I'm going to go and plug into the second equation now. So this time we have 15x minus 40 plus 400 equal to 445. So, it looks like we might be dealing with like an overtime equation here. So I'm going to distribute my 15x. And when I do 15 times 40, it's going to make a negative 600 plus 400 equal to 445. I'm going to combine my like terms. 15x is minus a 200, negative 600 plus 400 equal to 445. Now we're ready to add to get x by itself. I'm adding the 200 to both sides. So 15x is equal to 645. And we finish this off, that divide by 15 to both sides, and we should end up with x equal to 43. So we would need 43 hours there, which makes sense because, again, if I check that, my 43 that we just got is larger than 40. So that checks out. Now, I didn't leave myself much room. So forgive me for this last piece, but the thing to keep in mind is you do need to explain. Explain means I need a sentence in words. So I'm not going to write one in, but you should. You should definitely have a sentence in here that says something along the lines of, it couldn't be the first equation because 44.5 was not between 0 and 40. So because 43 hours is greater than 40, we knew it was the second equation. So that's how we solved for 43. So everything that we did, we would just sum it up. So just make sure to include that sentence. So it's a sentence necessary. I can write that in there for us. But you need words whenever it says explain. But I just can't fit anything. Couldn't even fit the word necessary. So bear with me on that. Okay, last one. When I look at this last one, you shouldn't overthink it. I would tackle the part where you can easily look at. So as I'm looking here, I'm going to focus on the line first. So I know that my slope is up 1 over 2. And if I go down 1 over 2, well, in here, I know I'm going to have a slope that's going to kind of not match up a little bit my y-intercept. To get to this point, it's going to look like this. So it's somewhere in between there. So there's only one that makes sense. If I don't even look at the first parts at all, because they all match, since all of those match, I don't care about that left side at all. But the only one that has the slope that I want is choice 2. And it makes sense because then you have the open circle there at 1, so there's no line underneath. We see it about 1/2 is where that y-intercept would have been, but we can get it right from the slope. So don't overthink, just use what you got as your tools. All right, guys, thanks for watching this video. This is the second recap of getting ready for our quarterly, and there will be one more video to follow.